In this video, we're going to be using the 0 to 5 volt signal that the KSC3 outputs when it detects knock to optimize our ignition timing. This is the ignition map that we're using at the moment. So you can see that we've already reduced the timing in a lot of places. This engine generally runs very close to the knock limit. And what we've got here, this is the thing that's going to make this possible, is we've got a compensation table here, which is the channel that the KSC3 will send to this ECU. So for example, the actual voltage for the lowest knock threshold breach is around 0.9 volts. So we've put that here as retarding -1 degrees. The medium level, it will output 2.4 volts, so we're retarding by 2 degrees there. And then the highest rating, which is going to be around 4.8 volts, we have got the ignition timing to output -6 degrees of ignition timing. So that's kind of a nuclear option, if you like. So the first part of this video is to data log this data, the engine load, the RPM, and the voltage that's coming from the KSC3. That voltage will indicate how bad the knock is. And we're going to log all that data in our engine ECU, not the KSC3. And at the end of it, we are going to be able to go into our ignition map. And if we press analog 1, which is going to be our KSC3 output, it's going to populate these cells with a voltage. So it's going to give us the average voltage that it received. We want as close to 0 as possible in this map. So if we're getting anything, I don't know, half a volt, 0.4 volt on average, even 0.3 volt on average, that will indicate that that's a cell in our table where we need to reduce the ignition timing. Just going to come to logs, enable log, and now we're going to drive around. So I can hear there we're picking up some very light knock, and we can see that the KSC3 is also picking that up. Should also note that when the KSC3 is picking up that engine knock, as I said, it's sending that 0 to 5 volt signal to the engine ECU, which will be retarding ignition timing. Call it there for the logs. Let's come to our ignition table and let's see what it's saying. So we're just going to overlay the KSC3 voltage over our ignition map, and we can see areas here, for example 5,900 RPM are basically, well, at the higher loads, because we're going to assume this is when we're lifting off. So we can see that it's saying for 5,900 RPM it's giving a 5 volt average input. So while that doesn't mean that we need to retard it by 6 volts, it does tell us that maybe -2 is not enough. So if we come back to the log, what else can we see? We're getting half a volt at 4,100 RPM. So we'll click the area there, and we'll see what we've got. So we don't have any ignition retard there at the moment. So half a volt is suggesting around -1 degrees of timing. So that is what we'll do. Just come back to it a minute, and that whole area there, sort of 4,100 down to 3,100, is around 0.7, 0.5 volts. So that's what I'm going to do. I'm going to the ignition table, come back to our ignition timing, and I'm just going to take out another 2 degrees of timing here, and we'll clear the data log, and we'll continue the process again with our new ignition timing. So just to put it all in a nutshell, the process: we've got our ignition map in the engine ECU. We log map RPM. In this case, you can log engine temperature, cylinder head temperature, engine load like boost, intake air temperature, whatever you want. In this example, we're using RPM against map. We go out with our map, we're logging the KSC3 0 to 5 volt signal. We go around, we drive different RPMs, different loads. We come back and we have a look at what our average is in each cell, and if we're seeing 0.5 volts, 1 volts, 0.2 volts, that suggests that we need to reduce the timing in those cells. We update our ignition map with the new settings that we've got, and then we repeat the process. We go out, we drive around, we do the data log, we come back, and then we see what the new settings are, the new average voltage that we're getting from the knock sensor, and we adjust the ignition timing according to what the knock is saying until we get it to where we want it to be. Obviously, if you have a rolling road, if you have a dyno, then you can do this stationary. You can just hold the engine at 4,000 RPM at whatever load that you want. You can do the ignition adjustments in real time. But if you don't have a rolling road, then it's a matter of going out, driving around and doing the logs that way. Hopefully it's clear what I'm doing. If it's not, feel free to leave a comment in the video or go to the Movichip website. Feel free to send us an email and we'll do our best to answer your questions. But that is, in essence, how you use the signal from the KSC3 knock sensor ECU to optimize your ignition timing. This product, the KSC3, is going to be available around Q2 2024. Again, go to the Movichip website, subscribe to the newsletter there, and then you'll get any updates. This is part of a series of videos on the KSC3. Link in the video description to that. There should be a thumbnail somewhere at the end of the video which is also linked to that. Like I said, a series of KSC3 videos going from setting it up to actually using it and for what it's intended for, i.e. optimizing ignition timing, which is what we covered in this video. But there's many videos in between. There's going to be a few more videos coming as well, just going into a bit more detail of the settings that it's got in there, what they do, and where is a good place to start with them. If you want to see more, subscribe to the channel. Like I said earlier, subscribe to the newsletter on movichip.com. That's it for now. Look after yourselves, and I'll see you again in the next video.